There is this very specific, very distinct flavor of anxiety that I think only a certain subset of tech enthusiasts really understand.
Oh, I think I know exactly where you're going with this.
Yeah, it's not the anxiety of like dropping your phone or spilling coffee on your keyboard.
Right, it's deeper. It's way deeper.
You're talking about the black screen.
The black screen, exactly.
Oh.
It's 3.0 a.m. You have this perfectly functional high-end PC sitting right there on your desk.
Oh, built it yourself.
Built it yourself, yeah. Runs Windows beautifully. But you decided, for some reason, that felt really logical at noon.
But feels completely insane right now.
Completely insane.
Yeah.
You decided you were going to force this machine to run macOS.
Right.
So you hit the power button. You see all these lines of text scrolling by like something out of the Matrix, and then
Just nothing.
nothing, just the void.
And you realize you have absolutely no idea why it stopped.
None.
You're just staring at this $2,000 paperweight. And that is, honestly, the quintessential Hackintosh experience. It really is. So, welcome back to the deep dive. Today, we are stepping into what I like to call the dark arts of computing.
I like that. The dark arts.
We're talking about the Hackintosh community, but we aren't just here to reminisce about the struggle. We are actually analyzing a specific tool that claims to fundamentally change this entire game.
Yeah, we have a pretty massive stack of documentation here for something called the Hackintosh EFI Generator.
And looking through this source material, it really does seem like a massive paradigm shift for this space.
It does. Because for the longest time, this hobby was essentially a secret society.
Yeah.
To get into it, you didn't just need a guide. You needed the patience of a saint.
And the investigative skills of a forensic accountant.
Literally. It was the ultimate barrier to entry.
Because the promise was always so tantalizing for people. You get the Apple software experience, Final Cut, Logic Pro, that whole ecosystem.
But without paying the Apple hardware tax.
Exactly. But the cost was your sanity.
Right, because you were taking hardware that Apple never, ever intended to support.
Like an AMD processor.
An AMD processor, some custom NVIDIA graphics card, a weird motherboard chipset. And you were trying to trick the operating system into believing it was running on a genuine Mac Pro.
Which is wild when you think about it.
Okay.
And that brings us to our mission for this deep dive.
Right.
We are looking at this EFI generator tool not just as a piece of software, but as a bridge.
A bridge for absolute beginners, yeah.
Because the documentation claims it uses these smart algorithms, probability meters, and tons of automation to essentially democratize this whole complex process.
It's trying to take the black magic out of the bootloader.
So let's start with the basics for anyone listening who hasn't ever bricked their computer before.
Good idea.
The core of this whole operation is something called OpenCore.
Right. OpenCore is the standard now. It's the bootloader.
How would you explain that to someone?
Think of it as the bouncer at the club.
Okay, I like that.
Before macOS can even start to boot up, OpenCore loads first. It checks your hardware and basically lies to the operating system.
Just hands it a fake ID.
Exactly. It ejects specific drivers, it patches the system memory, and it says, yes, I am a legitimate Apple device, please let me in.
But configuring that bouncer is famously difficult.
Difficult is an understatement. It requires a really deep understanding of computer architecture.
And that is where this tool's first module comes in. The documentation actually calls it Module 1, the brain of the operation.
Yep, the Plist parser and generator.
So to understand why we need a brain for this, we have to talk about the config.plist.
The dreaded config file.
Explain this file because it sounds simple, but it's really not.
In the OpenCore world, the config.plist is everything. It is a massive XML file that contains every single instruction for that bootloader bouncer we talked about.
How big are we talking?
Thousands of lines of code. You're dealing with keys, strings, data fields, booleans. And it is incredibly fragile.
How fragile?
If you miss a single angle bracket somewhere in line 800, the system won't boot. If you accidentally put a text string where the system is expecting a number, it panics. If you leave a blank space in the wrong place, black screen.
So traditionally, before a tool like this, how did people even handle that?
Mostly with a basic text editor and a lot of prayer.
Just manually scrolling through.
Manually scrolling. Or they used some early tools that were essentially just find and replace scripts.
Oh, that sounds dangerous.
It was. The problem with those scripts is that they were dumb. They didn't understand the actual structure of the XML file. They just looked for specific keywords.
So you'd fix one setting.
And the script would accidentally delete a crucial formatting tag in the process, breaking the whole file.
Like trying to fix the engine and accidentally ripping out the transmission.
Exactly. But if we look at the technical docs for this new EFI generator, specifically in the source util's Plist generator file, it's doing something fundamentally different.
It's not just treating it as raw text.
No. It uses a professional Plist library to parse the actual data structure.
Meaning it understands the grammar of the file itself.
Precisely. It guarantees a 100% valid XML structure.
So it won't even let you make a syntax error.
It physically cannot generate a structural error because the generator enforces the actual rules of XML.
That is a huge safety net.
It is. It ensures correct data types, too. So if OpenCore expects a Boolean, a true or false value, this tool ensures you literally can't accidentally type the word yes.
Okay, so that covers the safety aspect. But the docs emphasize these smart features. What is it actually being smart about?
It's smart about hardware detection. They call it smart device detection.
How does that work?
The system automates the recognition of your components. It queries your actual system to find the specific PCI IDs of your hardware.
So it's reading the unique fingerprints of your computer.
Right. It sees, okay, you have an Intel Comet Lake processor. It sees you have a very specific Realtek audio controller. And based on that information, it performs something called dynamic quirk assignment.
Quirk. I saw that term a lot in the OpenCore documentation. It sounds kind of cute, but I gather it's actually pretty annoying.
It is a massive headache. A quirk is basically a highly specific setting or a software workaround that's required for certain hardware behaviors.
Can you give an example?
Sure. Some older Intel processors handle USB power routing differently than actual Macs do, or they have a very specific issue with memory locking. It's called CFG lock.
And if you don't enable the quirk for CFG lock,
macOS just hangs on boot. It freezes forever.
And traditionally, how would you even know you needed that?
You'd have to read the Dortania guide,
Which is huge.
which is an incredible resource. The community relies on it, but it's essentially textbook. You'd have to identify your exact CPU generation, scroll down to the quirk section, cross-reference that with your motherboard manual.
It's literally homework.
It's hours of research just to click one toggle, but this tool's database just knows.
It does the cross-referencing for you.
It looks at your CPU and says, oh, Comet Lake, you need Apple XCPM CFG lock enabled.
Yeah.
You need devirtualize MIO enabled. It just applies them.
The documentation compares this to having an experienced master mechanic standing over your shoulder.
Someone who has worked on 1,000 of these exact cars.
Right. And it takes the guesswork out of the boot args as well, instead of you just typing cryptic codes.
Yes, it generates optimal boot arguments automatically. And critically, it handles SMBIOS generation.
SMBIOS, that's the digital identity of the machine, right?
Yes. This is the part where you tell Apple servers, I am a legitimate iMac 20,1.
But you can't just make up a random string of numbers.
No, it has to be a mathematically valid Apple serial number structure. But here's the catch. It cannot be a serial number that is currently in use by a real person out in the world.
Because if you accidentally clone a real Mac's serial number...
You create a huge conflict on Apple servers.
Yeah.
Eventually, your Apple ID gets flagged for suspicious activity, and you lose access to iMessage, FaceTime, the App Store.
It's a disaster.
A total mess. So this tool generates mathematically valid, safe serials for those services. It handles that whole identity generation so you don't have to roll the dice and risk your account.
Okay, so we have the brain handling all this underlying logic and safety, but a user still needs to interact with this thing.
Right.
Let's look at the user interface because Module 2 covers the visual Plist Editor.
This is the layer that actually makes the brain accessible to a normal human being.
Because if you've ever opened a raw config.plist, it is highly intimidating.
It's just a wall of code.
Right.
The visual Plist Editor transforms that terrifying wall into an interactive tree view.
So it looks more like a standard file explorer.
Exactly. You have the main sections of OpenCore ACPI, booter, kernel, and VRAM. And you can just expand them like folders.
And you can drag and drop elements.
You can drag and drop. It completely transforms the user experience from coding to simple configuration.
The notes compare it to using a Word document instead of writing raw HTML. You don't need to know the underlying syntax. You just find the NVRAM section and change the value you want.
And it has actual safety nets built directly into the UI, which is crucial. It uses a utility called ocvalidate for real-time validation.
Is ocvalidate a standard tool?
It is the official standard tool from the original OpenCore developers.
Okay.
But usually you have to run it manually in a command line terminal. You type out the directory command, drag in your Plist file, hit enter, and then try to decode a bunch of dense error messages.
That sounds tedious.
It is. But this visual editor runs it constantly in the background. As you type or as you change a dropdown, it is checking your work instantly.
So if I try to type something that breaks the OpenCore rules, it yells at me immediately.
Before you can even click save. It totally prevents type errors like we mentioned earlier, putting text where a number belongs. And it has full undo and redo functionality saved right in your local storage.
Which sounds incredibly basic for any software in the 2020s, but for a hacking tool, that is a huge luxury.
It is massive. In a normal text editor, if you accidentally highlight and delete a block of XML code and then hit save,
It's just gone.
it's gone. And if you broke the structure, good luck finding exactly which line is missing a bracket. This undo feature gives users the freedom to experiment without that constant fear of immediate destruction.
Okay, so we've got the master configuration file sorted out, but a Hackintosh isn't just one text file. It is a whole ecosystem of drivers and specific tools. Which brings us to Module 3, the downloader and Kext updater.
Because the config.plist is really just the map. You still need to gather all the physical parts.
Right.
And in the Hackintosh world, those parts are called Kexts.
Kexts, which stands for kernel extensions.
Exactly. They are basically drivers.
Okay.
On Windows, you download an X file to install a driver for your graphics card. On a Hackintosh, you need these Kext files to make your non-Apple hardware play nice with the strict macOS kernel.
And you have to scrounge these up from all over the internet?
Usually from random GitHub repositories, yes. You need the main OpenCore binary file itself. You need specific drivers for your audio chip, your Ethernet port, Wi-Fi, Bluetooth.
And you have to make sure they are all actually compatible with each other.
Welcome to dependency hell.
That is the official term, right? Dependency hell.
It really is. Most of these essential Kexts are maintained by a brilliant group of developers called Asinanthera. They're pretty much the heroes of this entire community.
Right, they make tools like Lilu and whatever green.
Lilu, whatever green, virtual SMC. But these tools update constantly. So if you manually download a version of Lilu that is too old and a version of whatever green that is too new,
They won't talk to each other.
they conflict and the system panics.
So this third module just automates that entire gathering process.
Yes, it connects directly to the GitHub API, version 4. It fetches the exact OpenCore EFI, the drivers, and the tools automatically.
And it mentions using SHA-2556 checksums. That's for integrity.
Right, to ensure the files weren't corrupted during the download or tampered with by a third party.
It also mentions an offline mode, so it caches these files so you can keep working even if your internet drops out. But the feature that really caught my eye in the source material is the smart version selection.
That is a lifesaver.
Because it explicitly says it does not just grab the newest version available. Why wouldn't you always want the newest version of a driver?
Because in the Hackintosh ecosystem, newest does not always mean best.
How so?
Sometimes a developer updates a driver to support the absolute latest version of macOS, say macOS Sequoia. But making it work for Sequoia might completely break its compatibility with an older version, like macOS Catalina.
Oh, I see.
So if you were specifically trying to build a machine to run Catalina and you just blindly download the newest driver from GitHub, you might instantly break your system.
So this tool checks your intended target OS before it downloads.
It acts like a highly curated app store. It grabs the most compatible version for your specific hardware and your specific OS combination.
It just avoids the conflicts before they even have a chance to happen.
It completely automates the legwork. You don't have to read 10 pages of release notes just to download a Wi-Fi driver.
That brings us to Module 4. And this is the part of the documentation that feels a little bit like magic, or maybe just really aggressive data science.
The probability meter in PC Builder?
Yeah, it's located in the source utils probability calculator file.
And honestly, this specific module is the huge differentiator. This is what takes it from being just a useful tool to being an actual advisor.
It claims to give you a definitive success probability. Like, it will literally output 85% chance of success. How can it possibly calculate that?
It's all based on data. The documentation explains that it uses a weighted scoring system based on over 50 different hardware factors.
50 factors.
Yeah, and it runs that through a machine learning model that has been trained on over 10,000 documented successful Hackintosh builds.
So it's looking for established patterns of success.
It's looking closely at your specific combination of parts. It knows from the data that an Intel Core i9 processor paired with a Gigabyte Z490 motherboard is what the community calls a golden build.
A known rock-solid quantity.
Exactly, so it scores that combination very high. But if you throw in a component that is historically known to be problematic,
Like what? What's a bad part?
Let's say a specific Samsung PM981 solid-state drive.
Okay.
That specific drive is notorious in the community for having a memory controller that violently conflicts with how macOS handles storage. It causes completely random, unfixable crashes.
So if you add that drive to your virtual build, the tool flags it immediately.
It performs a comprehensive risk assessment. It identifies the specific components that drag your probability score down. It might give you a warning saying, hey, this specific Intel Wi-Fi card is not supported natively. You're going to need a very complex workaround to make it function.
And this ties directly into the PC Builder feature, because you can use this interface before you even pull out your credit card to buy the parts.
That is the personal shopper aspect. It shifts the entire workflow of this hobby.
From buy parts and pray they work,
To intelligently plan the build and verify compatibility first. You can plug in your ultimate dream list of parts, run the compatibility report against their database, and it even tracks the pricing and budget for you.
I love that. It totally gamifies the success rate. You're going to want to tweak your parts list until you hit that 100% score before you even pick up a screwdriver.
And it prevents that awful heartbreak of buying a $500 graphics card only to realize after the return window closes that it has absolutely zero driver support in macOS.
Which, reading between the lines of the forums, happens way more often than people like to admit.
Far, far too often.
Okay, so let's say we've planned the perfect build. We have a great probability score. We've downloaded all the correct files. Now we have to actually execute the installation.
Right.
Which takes us to Module 5. Hand-holding the process.
The wizard.
The interactive install wizard. Now, I have seen Hackintosh installation guides. There are a million static text guides. There are endless YouTube tutorials. What makes this wizard any different?
Dynamic rendering. That is the absolute key here.
Meaning it changes based on user input?
Exactly. Most guides out there are static. You watch a video and the guy says, okay, go into your BIOS and change these 5 settings. But BIOS menus look completely different depending on the manufacturer.
Oh, true. An ASUS menu looks nothing like an MSI menu.
And Intel settings are named completely differently than AMD settings.
So if you are a beginner, you get lost at step 1 because your screen doesn't match the YouTube video.
Precisely. This wizard starts by asking you what you actually have. You tell it, I have an AMD Ryzen processor running on an MSI motherboard.
And then it dynamically generates a custom set of instructions just for that hardware.
It filters out all the irrelevant noise. It will not show you Intel-specific memory settings if it knows you're on an AMD system.
It customizes the map so you don't get lost.
And it validates the steps as you go. It creates an interactive checklist. You have to physically check off Disable Secure Boot. You have to check off Enable XHCI Handoff.
Which are the classic beginner pitfalls, right?
They are the reason 90% of first attempts fail. Just skipping one tiny toggle in a submenu of the BIOS, this wizard forces you to pay attention to every single one.
And then inside this module, there's also the boot args builder. We touched on boot arguments earlier, but the interface change here is really about translation, isn't it?
It's completely about translating geek into plain English.
Because boot arguments are basically cryptographic text strings.
Yeah, things like agdpmod equals pkera or -wegnoku.
It looks like you're trying to hack the Pentagon mainframe.
It really does. And if you make a single typo in one of those strings, the fix doesn't work. The builder interface replaces all those confusing strings with simple checkboxes.
So it just says enable audio.
Enable audio, disable discrete GPU, turn on verbose mode.
And the notes say it handles conflict detection here as well.
Yes. If you accidentally select 2 arguments that contradict each other, like say you enable a specific graphics patch, but you also select a box that disables that same graphics card, the tool warns you immediately. It demystifies the entire startup sequence.
Now, let's be realistic for a second. Even with all this amazing hand-holding and validation, things can still go wrong.
Oh, absolutely.
Or maybe you have a perfectly working system, you decide to update your software, and suddenly it breaks. Module 6 offers what they call advanced tools for analysis.
The diff tool.
Diff, as in difference.
Yes. This is a concept they borrowed straight from professional software engineering environments. When a piece of code suddenly breaks, the very first question a developer asks is always, what changed?
Right. What did we do differently today?
The diff tool allows you to upload your old, perfectly working config file alongside your new, broken config file.
And it compares them side by side.
Character by character. It gives you a highly visual representation with color-coded additions in green and deletions in red. You can see exactly what changed between Tuesday and Wednesday.
So you might look at it and say, oh, wow, I accidentally deleted the entire driver entry for my keyboard when I was just trying to change the background theme.
Exactly. And trying to spot a deleted line manually in a 2,000-line XML file is basically impossible. Your eyes just glaze over after 5 minutes.
But this tool highlights your mistake in neon red.
It is an absolute troubleshooting lifesaver. And paired right alongside that is the OpenCore validator we mentioned back in Module 2, but here they expose it as a standalone diagnostic tool.
The technical documentation mentions that it uses WebAssembly. Why is that specific detail important for the user?
WebAssembly is great. It allows your web browser to run raw binary code, like actual C++ code, directly on your local machine.
Instead of doing what?
Instead of uploading your personal configuration file to some remote server to be processed and checked.
Ah, so it's much faster and it's totally private.
Exactly. It's doing the heavy lifting right there in Chrome or Safari.
And the validator has an autofix feature.
For simple structural errors, yes. If you have a formatting error in the Plist that violates the official OpenCore specification, it can often just automatically patch it for you.
It's like a smart spell checker that actually prevents your computer from failing to boot.
Pretty much.
Okay, so let's say we've passed all the tests. We've got the system running. We boot up. We see the beautiful macOS desktop. The dock pops up. We are completely done, right?
That is the ultimate rookie mistake.
I knew it.
You're never truly done just because you finally reached the desktop screen. That phase is what the community calls the uncanny valley of Hackintoshing.
The uncanny valley, meaning it looks exactly like a Mac, but it just doesn't quite feel like one.
Exactly. It looks right, but maybe the window animations are super choppy because your hardware acceleration isn't actually engaging.
Right.
Or maybe the computer absolutely refuses to go to sleep when you close the lid. Or your USB ports keep randomly disconnecting your external drive.
And that is exactly where Module 7 comes into play. The finish line, post-install, and knowledge base.
The post-install checklist.
The documentation is very clear here. It acknowledges that just installing the OS is barely half the battle. This checklist is designed to guide you through the tedious refinement phase, and it prioritizes tasks by high, medium, and low importance.
Which is smart, so you don't get overwhelmed.
So what would classify as a high-priority post-install task?
USB mapping.
Without a doubt.
USB mapping, why is that such a big deal?
It is the absolute bane of every Hackintosher's existence. Here's the issue. macOS has a very strict hard-coded limit on USB ports. It only allows exactly 15 ports per USB controller.
Okay, but most modern PC motherboards have way more than 15 ports, don't they?
Way more. When you count the physical ports on the back, the headers on the motherboard for the front panel, and internal connections for Bluetooth and RGB lighting, you easily hit 25 or 30 logical ports.
So what happens when macOS sees 30 ports but only allows 15?
It just randomly chops off everything past 15.
So if you don't manually map them, meaning you create a custom file that tells macOS exactly which physical ports you actually want to use and what type they are, your super fast USB 3.0 ports might get downgraded to slow 2.0 speeds.
That's frustrating.
Or your internal Bluetooth card just vanishes. Or, very commonly, the system instantly wakes back up every time you try to put it to sleep because a random unused USB header is sending a ghost signal.
And doing this mapping process manually is pretty tedious, I assume?
It is incredibly tedious. You have to plug a flash drive into every single port one by one, record the data. The checklist essentially holds your hand through that whole miserable process.
It also covers power management optimization, making sure your CPU actually speeds up when you need power and slows down when you don't.
Which is vital for saving energy and keeping the system from overheating.
And, of course, the final boss. iMessage setup.
The holy grail, getting those blue bubbles to work.
So the checklist ensures you don't settle for a half-baked, unstable system. But if you do get stuck during any of this, there is the knowledge base feature.
Which is really cool because it's deeply integrated with AI.
Yes. The source material notes it's a centralized JSON database that feeds directly into an AI assistant.
It's not just a standard static FAQ page where you have to hit C3RLF to find your problem. It's designed to answer highly specific contextual questions.
Like what?
Like if you ask it, why is my screen flashing green every time I try to play a video on Apple TV+?
Which I'm guessing is some sort of digital rights management issue?
It is. It's a DRM failure.
Right.
And the AI can instantly parse your specific hardware profile and tell you exactly which boot argument or which specific setting you need to change to fix the DRM for your exact graphics card.
That is incredibly powerful, which naturally brings us to the actual architecture of the tool itself. Module 8 covers the tech stack, because hearing all this, it's clear this isn't just a simple Python script running in a terminal.
No, it's a fully fledged modern application.
The docs say the front end is built with React 19, TypeScript, and Vite.
That combination ensures the web interface is incredibly fast, very responsive, and structurally reliable. And they use Tailwind CSS for the styling.
So it natively supports dark mode and just generally looks like a professional app?
Right. But there's also a dedicated desktop version.
Yes, built with something called Tori. Now, how is Tori different from something like Electron? Because I know popular apps like Discord and Spotify use Electron.
Electron is notoriously heavy. It basically bundles an entire separate Chromium web browser inside the app just to render the interface. It eats up your RAM.
Right, the classic Chrome RAM hog issue.
Exactly. Tori is much more lightweight. It uses the operating system's native web view to render the UI. But the really interesting part is the backend, the engine that actually does all the heavy computational lifting, like parsing those massive XML files and calculating the SHA-256 checksums.
That part is written in Rust.
Rust, the language every developer is obsessing over right now.
Why is Rust such a big deal for a tool like this?
It is blisteringly fast, but more importantly, it is inherently memory safe. By design, it physically prevents a whole class of common bugs and security vulnerabilities related to how memory is accessed. By using Rust for the backend, this tool ensures it can handle compiling those massive, complex Plist files instantly without ever bogging down your system or crashing midway through.
And the most futuristic part of this whole architecture has to be the AI integration. The documentation specifically mentions using Google's Gemini.
Yes, they are leveraging Gemini for intelligent configuration generation.
And the goal, and this seems to be looking a little bit ahead into the future roadmap of the tool, is to have fully AI-powered hardware detection and troubleshooting.
Just imagine the workflow. Imagine just dumping your computer's raw, chaotic system error log directly into the tool.
And the AI just reads it.
The AI reads it and says, I see exactly what happened. You have a customized BIOS firmware that is directly conflicting with this specific version of your audio driver. Here is the exact patch you need to apply.
That is expert-level diagnosis on demand.
It totally replaces the need to post your log on a forum and then wait 3 days hoping some grumpy expert replies to you.
Which perfectly segues into the community aspect of this project. The tool is open source, released under the MIT license.
Which is fantastic.
Right.
It means the software is completely free, the development is transparent, and anyone in the community can contribute to making it better.
And you can inspect the actual source code to make sure it's not doing anything malicious.
Right. But the documentation makes a point to end with a very specific, familiar quote, "With great power comes great responsibility."
The Spider-Man rule.
The Spider-Man rule definitely applies here. Because even with all this brilliant automation, all these safety nets, you are still modifying hardware and software at a very deep fundamental level.
You are almost certainly voiding warranties.
You are intentionally running a proprietary operating system on hardware it was fundamentally never designed to touch. The tool heavily emphasizes that the user still needs to be responsible.
It makes the technical process significantly easier, but it doesn't remove the inherent risks of hacking your own hardware.
Exactly.
So bringing all of these modules together, taking a step back, what are we actually looking at here? Is this really just a better text editor for configuration files?
No, I don't think so at all. I think we are looking at a complete transformation of the entire hobby.
How so?
The Hackintosh EFI Generator manages to balance the needs of two very different, often conflicting groups of people.
The absolute beginners and the hardcore experts.
Exactly. It provides the install wizard and the visual PC builder for the beginners. It's an accessibility layer. It gives them a safe, guided path up the mountain.
But it doesn't alienate the veterans.
Right. It keeps the granular diff tool and the raw Plist editor available for the experts. That's the depth layer. It doesn't dumb down the complex process. It simply facilitates it better.
It really does raise a fascinating question about the future of tinkering in general.
It does.
Because I remember when tinkering with a computer meant literally burning your fingers on a soldering iron or writing actual assembly code by hand. Now, tinkering essentially means managing and tweaking these highly sophisticated, automated software workflows.
And the question becomes, as the barrier to entry slowly disappears, does the hobby lose its core soul?
Right. If an AI mechanic can perfectly calculate, source, and configure the engine of your machine for you, and all you do is click generate, at what point is it no longer really your car?
I hear that argument,
Yeah.
but I would argue that this tool just puts the focus back on the actual end result.
What do you mean?
Instead of spending 3 agonizing weeks fighting with XML syntax errors and kernel panics, you can spend that same time actually learning how to optimize your audio workflow or learning how to color grade a film in Final Cut Pro.
It moves the entire baseline up.